Okay, so let's take a look at the last two problems for 15, E and F. And so again, notice it's log equation, and this one has multiple logs. And so even if you were to make this log go to the other side, you would still have an extra term here. And so as long as you have multiple terms and not just log equals log on the other side, you have to condense using your properties. And so in this case, we have a plus. So remember, plus was code for multiplication. And so we have log base 4 of x times x minus 3 equals just 1. And so here we find ourselves with a dilemma once we condense. We don't have a log equal to another log anymore, so we can't just set these equal to each other. In this particular scenario, we have a log equal to just a number. And even if you were to clean this up and make it where it was log base 4 of x squared minus 3x equals 1, you'd still have the same dilemma. So here is what we do to get out of this predicament. We need to rewrite this in exponential. So you must rewrite an exponential form. This will help us be able to free our trapped exponent. So if we're trying to free something trapped, we always do the opposite. And so the opposite of logs is exponential form. So what does that mean? Well, 4 to the first power equals x squared minus 3x. So this is me rewriting it in exponential form. The good news is 4 to the first power is just 4. And now I have a quadratic, so 0 equals x squared minus 3x minus 4. I could factor that. So I get 0 equals the factors x minus 4x plus 1. And so then I get x equals 4 and x equals negative 1. But it is a log function, so we must check. So let's take a few seconds to just do a soft check here. Let's check 4. 4, that would be log base 4 of 4, which is just 1, so that's pretty easy. 4 minus 3 is 1, and so that would be 0. 1 plus 0 equals 1, and so the 4 checks, so we can keep that one. Let's check negative 1. Ah, look, log base 4 of negative 1. We can't have a negative inside of a log, so we get to reject this one. Our only answer is x equals 4. Let's look at F. F is very similar in the fact that there's not a natural log on the other side, and even if you were to move this natural log over to the other side, you'd still have 2 plus ln x, and as long as you have multiple terms on a side, you cannot use the one-to-one property. So here all we're forced to do is condense. Remember, subtraction means code for denominator. So we have natural log x plus 2 over x equals 2. Again, since we don't have natural log on the other side, we're not allowed to just set these two things equal. That's not how we solve this one. We must rewrite in log form. This one, of course, since it's natural log, we're going to use e. So this would be e to the second power equals x plus 2 over x. This one takes a few more minutes to solve, but we can do it. So we're going to multiply both sides by x. So that would give me x e to the second power equals x plus 2. So now we have x on both sides. Remember, the goal is to solve for x. So we have kind of a dilemma, but that's okay. I'm going to move this x over, so I have x e squared minus x equals 2. And anytime I have multiple terms that have a common factor, I could factor it out. So I'm going to factor out an x. That gives me e squared minus 1 equals 2. And now I could just divide both sides by e squared minus 1, e squared minus 1. And so my answer is x equals 2 divided by e squared minus 1, and we're allowed to round on this one. So it gives me x equals 0.3130. Of course, you want to do a quick soft check. We check by plugging it in. That would be 0.31 plus 2 would still be a positive, and you can have a positive. 0.31, that's still a positive, so that's okay. So we get to keep it. So x equals 0.3130. is my answer.